Good morning to everyone. I'm Dr. Sumi MS. The topic of my today's presentation is Combinational Circuits Design from Unit 2 Combinational Circuits and Logic Family of Digital Logic Circuits and Design. On completion, the students will be able to define a combinational circuit, list down the different types of combinational circuits, understand the different types of binary adder and subtractor circuits. Combinational circuits design. A combinational circuit is a type of digital logic circuit whose output depends on the present input values only and does not depend on the past input and output values. Therefore, it does not need any memory element in its circuit that stores the previous inputs and outputs. Instead, it consists of a certain number of input lines to apply the current input values and a certain number of output lines. The most important characteristics of a combinational circuit is that it does not have any feedback path between the input and the output. Therefore, the combinational circuits can also be categorized as open loop systems. So this diagram represents a combination circuit with n input variables and m output variables. It's an n cross m system. Here we can see that there are only three key elements that are present in the circuit diagram. They are the input lines, the processing unit and the output lines. The input lines are used to enter the input values into the combinational circuit. The processing unit is the main element that processes the input values depending on the type of the circuit, and it may be an adder or a multiplexer or a coder circuit. Output lines. The output lines are used to take results generated by the circuit. Characteristics of combinational circuits. The following are the main characteristics of combinational circuits. The output of a combinational circuit at any instant of time depends only on the present input values at that particular instant of time. They do not use any kind of memory element. Thus, the previous state of input and output values have no effect on the present operation. The output of the combination circuit can be entirely predicted using its logical operation as well as input values. Combination circuits produce an instantaneous output in response to any change that occurs in the input applied. Types of combination circuits. The combination circuits are important components of digital systems depending on the function that is taken care. There are various types of combination circuits such as binary adders, binary subtractors, multiplexers, demultiplexers, encoders, decoders, comparators. Binary adders. A binary adder is a combinational circuit that performs the addition of binary digits or bits. Depending on the design and configuration, there are two types of binary adders, namely half adder and full adder. A half adder is a combination circuit with two inputs and two outputs. It is the basic building block for the addition of two single bit numbers. The circuit has two outputs, namely sum and carry. So this is the logic diagram representing a two input half adder with A and B as input and sum and carry as output. Full adder. The full adder is designed to overcome the drawback of a half adder, which is able to add only 2 bits. Therefore, the full adder is a 3 input and 2 output combination circuit. The inputs are two 1 bit numbers A and B and a carry from the previous addition. And the outputs are sum and final carry output. So this diagram represents the logic diagram of a full adder with A, B as inputs and C in as the carry input and sum and C out as the outputs. Binary subtractor. Binary subtractor is a combinational logic circuit that is used to subtract one binary number from another. Similar to binary adder, there are two types of binary subtractors, namely half subtractor and full subtractor. A half subtractor is a combination circuit with two inputs A and B and two outputs, that is difference and borrow. It produces the difference between the two binary bits at the input and also produces an output borrow to indicate if a 1 has been borrowed. In binary subtraction between A and B, A is called as the minuend bit and B is called as the subtractant bit. This is the diagram representing the logic diagram of a half subtractor with inputs A and B and difference as borrow as output. For a full subtractor, it is also a combination circuit with three inputs A, B and a borrow input and two outputs difference and borrow out. Here A is the minuend, B is the subtractant, B in is the previous borrow bit produced by the previous stage and D is the difference output and B out is the final borrow output. The diagram represents the logic diagram of a full subtractor. Quiz questions on combinational circuits design. What are the different types of combinational circuits? What are the two types of binary adder circuits? Draw the logic diagram of full subtractor circuit. Thank you.